Question number 1. If the frequency of the human heart is 1.25 Hz, the number of beats per minute in 1 minute is. So we have given the frequency is equals to 1.25 Hz. We have to find the number of beats in 1 minute. So 1 minute which equals to 60 seconds. So that's why we have to multiply the number of beats in 1 minute. So 1.25 into 60, which gives you 75. So the correct option is option B, 75 beats per minute. Okay, the next sum we have in the equation of motion in a simple harmonic motion is d square x by dt square equals to minus omega square x, d square x by dt square is equals to minus omega square t, and d square x by dt square is equals to minus omega x, or d square x by dt square is equals to minus omega t. We have in the simple harmonic motion acceleration is equals to change in the velocity upon time, so that is d square x by dt, changing the dt square, which is equals to minus omega square x, that is the angular velocity omega into x. So the correct option is A, d square x by dt square is equals to minus omega square x. Okay, two simple harmonic motions are represented by the equation y1 is equals to 10 sin pi by 4 12t plus 1, and y2 is equals to 5 sin 3 pi t plus 3 cos 3 pi t. The ratio of the amplitudes are 1:1, 1:2, 3:2, or 2:3. So we'll write the equations. Y1 is equals to 10 sin pi by 4 12t plus 1. So we can make this as sine of 3 pi t upon 4 3 pi t plus this will be pi by 4. Okay, next y1 becomes this, y2 is equals to 5 of sine 3 pi t plus root 3 cos 3 pi t. Okay, so we multiplied by 2 and divided by 2, so that gives you sine 3 pi t into half plus root 3 by 2 cos 3 pi t. That is sine a plus sine b, sine a plus cos b. That gives you 10 sine a 3 by 2 plus b, that is pi by 3. Okay, so that is your y2. So for in both the cases we have your amplitudes a1 equals to 10 and a2 equals to 10. This is your a1, this is your a2. a1 a2 equals to 10. So the ratio is a1 upon a2 gives you, that is 1:1. So the ratio is 1:1. So the correct option is A. Next, a particle executing simple harmonic motion with an amplitude A. The distance traveled by the particle in one time period is 0, A, 2A, and 4A. The particle, while performing in simple harmonic motion, it covers a distance of 4 times of the amplitude. So the correct option is D, it is 4A. The displacement versus time curve for a particle performing SHM is shown. Which of the following statement is correct? Phase of the oscillator is same as time equals to 0 and time equals to 2 seconds. Phase of the oscillator is same at t equals to 2 seconds and t equals to 5 seconds. Phase of the oscillator is same as t equals to 1 second and t equals to 7 seconds. Phase of the oscillator is same as t equals to 1 second and t equals to 5 seconds. Here there is a displacement versus time graph. So the phase, as we can see here, it is same when the time is equals to 1 second and time is equals to 5 seconds. Also the phase will be same when t equals to 2 seconds and t equals to 6 seconds. So we have the correct option D, where the phase of the oscillator will be same when t is equals to 1 second and t equals to 5 seconds. Okay. Two particles executing simple harmonic motion of the same amplitude and frequency along the same straight line. They cross one another when they are going opposite directions, in the phase difference between them when their displacements are 1/2 of their amplitude is 60 degree, 30 degree, 120 degree, and 150 degree. So here we have two particles which are performing simple harmonic motion, out of which one is having a displacement half of their amplitude. So we have the equation for the SHM is y is equals to a sin omega t plus psi. As the displacement is equals to half of that amplitude, y becomes equals to a by 2. So we can write a by 2 equals to a sin omega t plus psi. That becomes equals to sin omega t plus psi equals to half. So sin theta we get, it is equals to 30 degree, or it can be 150 degree. So therefore omega t plus 5, both the particles which are performing simple harmonic motion, they can have two angles, they can have two phases, that is 30 degree and 150 degree, when they are going opposite in the opposite direction. So the phase difference between both of them will be 130 minus 150 minus 30 degrees, that is 120 degree. So your correct option is C, 120 degree. Okay, a particle executing simple harmonic motion is described by the displacement function xt equals to a cos omega t plus psi of the initial if the initial time equals to 0, position of the particle is 1 centimeter, its initial velocity is pi centimeter square inverse and the second inverse, and its angular frequency is pi s inverse. Then the amplitude of its motion is pi centimeters, 2 centimeters, 2 centimeters or 1 centimeters. So here we have a particle performing simple harmonic motion, which is described by x equals to a cos omega t plus psi. Okay, at time t equals to 0, the x equals to 1 centimeters they have given, so position of particle is 1 centimeters, so we have 1 equals to a cos psi. Okay, let this be equation 1. Next we have the condition for velocity, where velocity is equals to change in displacement upon time. So dy dt of the equation a cos omega t plus psi, so that will give you minus of a omega sine omega t plus psi, that is your velocity. So at the position of the particle, its initial velocity is pi, its initial velocity when the time is equals to 0, the velocity is equals to pi, that is minus a omega sine psi. Okay, omega t, the t becomes equals to 0, so we can take pi upon omega is equals to minus a sine psi. Okay, this is your equation. So here we have the value of its angular velocity frequency is pi, so angular frequency omega is given as pi second inverse, so we have pi upon pi is equals to minus a sine psi, that gives you 1 is equals to minus a sine psi. Okay, this is your equation 2. So from the equation 1 and equation 2, we can add them and we can square them and add them. Adding and squaring the equations, we get a square sine square psi plus a square cos square psi is equals to 2. Okay, so a square has sine square plus cos square theta psi becomes equals to 1, so we have a square is equals to 2, so a equals to 2 centimeters. So the correct option is B. So correct option is C, root 2 centimeters. Which of the following expression does not represent a simple harmonic motion? Okay, x is equals to a cos omega t plus b sin omega t, x equals to a cos omega t plus alpha, x is equals to b sin omega t minus beta, or x equals to a sin omega t cos square omega t. Simple harmonic motion, basically it's represented by a sine or a cosine function, or a linear combination of both of them, or the sine function or a cosine function. So basically the first three we have, there is a cos function over here, there is a sine function here, and there is a combination of both of them over here. But in the fourth one, in the D one, it is a product of the two function, which does not represent a simple harmonic motion. Hence we have D, which is not a simple harmonic motion. The function sin omega t minus cos omega t represents a simple harmonic motion with the period pi by omega, a simple harmonic motion with the period 2 pi by omega, a periodic but not simple harmonic motion with the period pi by omega, a periodic but not a simple harmonic motion with the period 2 pi by omega. So basically we have the function solution. We can write the function is sin omega t minus cos omega t. We multiply it by root 2, that is here we get 1 upon root 2 sin omega t minus 1 upon root 2 cos omega t. So this becomes a formula. Solving it, we get sin omega t cos pi by 4 minus cos omega t sin pi by 4. Okay, this is cos sin a cos b minus cos a sin b, so that gives you root 2 sin a minus b. So here comparing it with the formula sin y is equals to a sin omega t minus psi, so we have here the period which is equals to 2 pi upon omega. So it is a simple harmonic motion with a period 2 pi upon omega. So second is the right option. Okay, the vibrating motion of a particle is represented by x equals to 2a cos omega t plus a cos omega t plus pi by 2 plus a cos omega t plus pi plus a by 2 cos omega t plus 3 pi by 2. The resultant amplitude of the motion is 9a by 2 root 5a by 2 5a by 2 or 2a. So we have the solution x equals to, we write the entire equation as it is, then we take it in the format 2a cos omega t. Here also a cos omega t, it becomes minus sin omega t. Again here it is 180, so it becomes minus a cos omega t. Next a by 2 cos omega t. Cancelling the other terms, we have the resultant amplitude, resultant displacement, the resultant equation to be a cos omega t minus a by 2 sin omega t. So the resultant amplitude is given by under root of the addition of all the amplitudes. So a by 2 minus a by 2 the whole square, that gives you root 5a by 2 the amplitude. So the resultant amplitude is option B, root 5a by 2. Now in a simple harmonic motion, the it is represented by d square x by dt square plus alpha x equals to 0. Its time period is root 2 pi 2 pi under root alpha, 2 pi alpha, 2 pi under root 2 pi by under root alpha, and 2 pi by alpha. So here we have the equation d square x by dt square equals to plus alpha x equals to 0. Okay, we can write it d square x by dt square equals to minus alpha x. Okay, we can compare it with the equation as such of SHM, d square x by dt square is equals to omega square x, where we get omega square equals to alpha, where omega equals to under root of alpha. Okay, then we have the equation for time period t, which is equals to 2 pi upon omega. So we have 2 pi upon under root alpha. So the time period is given by 2 pi under root alpha. Okay, if x, v and a represent the displacement, the velocity and the acceleration of a particle executing simple harmonic motion of time period t, then which of the following does not change? At by v, at plus 2 pi v, or at by x, or at square plus 4 pi square by v. So we have to take each and every term and see which does not change. I'll take the c1, at by x, that is acceleration time upon displacement. So we know acceleration, which is equals to omega square x upon t upon x. So this gets cancelled, we get omega square t. We know omega is equals to 2 pi by t, so omega square will become 4 pi square upon t square. So hence 4 pi square upon t square into t, that gives you 4 pi square upon t, which is a constant. Hence the value at by x will not change. Correct option is C. Two particles executing SHM of the same amplitude and frequency on parallel lines, they pass on another when moving in opposite direction each other when their displacement is half of the amplitude. The phase difference between them is 0, 2 pi by 3, pi, or pi by 6. Okay, now in this we have again we have two equation, we have an equation for a particle, y equals to a sine omega t plus psi. Here the displacement is half of the amplitude, so y is equals to half of the amplitude a by 2. So again we take a by 2 equals to a sine omega t plus psi, that gives you half is equals to sine omega t plus psi. So omega t plus psi comes out to be 30 degree, and they are in opposite direction, so it is 150 degree and 30 degree, where the phase difference between them will be 120 degree. Hence that gives you 2 pi by 3. The circular motion of a particle with constant speed is periodic and simple harmonic but not periodic, neither periodic nor simple harmonic, periodic but not simple harmonic. Okay, circular motion, a particle performing circular motion with a constant speed, its motion is periodic, but it cannot be simple harmonic, as it has to go to an it is not going to and fro at a fixed point. So we cannot say it is periodic simple harmonic, but the circular motion with the same speed, we can say it is periodic. So the option is D, it can be periodic but not simple harmonic. A particle executing simple harmonic motion with an amplitude a and angular frequency omega, the ratio of the maximum acceleration to the maximum velocity of the particle will be, so it is omega a, omega square a, omega, or omega square a, omega square by a. Okay, so for maximum velocity we have v max, which is equals to omega a. Okay, and for maximum acceleration that is a max, we have acceleration is omega square a. So the ratio of maximum acceleration to maximum velocity, so that is a max upon v max will be omega square a upon omega a. That gives you omega. So the correct option is C, omega. Particle executing SHM, the phase difference between the velocity and the displacement is, okay, we have a particle performing SHM. The options are 0, pi by 2, pi and 2 pi. So we have a particle performing SHM here. For the equation is x equals to a cos omega t. We'll find the velocity, which gives you change in distance upon time, that is d by dt of a cos omega t. That comes around minus of a omega sine omega t. We can write it as a omega cos of omega t plus pi by 2. Okay, that is for the velocity. So for the phase of displacement, we have phase of displacement psi 1, which is equals to omega t, and for the phase of velocity we have psi 2, which is equals to omega t plus pi by 2, which we found now. Okay, so difference between the phase of the phase difference between the velocity and displacement is psi 2 minus psi 1, which is equals to omega t plus pi by 2 minus of omega t, that comes out to be pi by 2. So the correct option is B, pi by 2. Question number 17. Which of the following relationship between the acceleration a and the displacement x of a particle executes simple harmonic motion? So we have the relation for the we have the options a equals to 2x square, a equals to minus 2x square, a equals to 2x, and d equals to a equals to minus 2x. Okay, we know that the acceleration for a simple harmonic motion is given by minus omega square x, so which is represented by the equation d, a is equals to minus 2x. A particle executing SHM according to the equation x equals to 5 cos 2 pi t plus pi by 4. In SI units, the displacement and the acceleration of the particle at time t equals to 1.53 seconds is options A minus 3.0 meters 100 meter per second square, 2.54 meters 200 meter per second square, 3.54 minus 3.54 meters 140 meter per second square, or 3.55 meters 120 meter per second square. So here we have an equation x equals to 5 cos 2 pi t plus pi by 4. Okay, we can compare it with the general equation for the SHM is x equals to a cos omega t plus psi, where we get omega is equals to 2 pi, the amplitude is equals to 5. Okay, so here after time t equals to 1.5 seconds, so we substitute the time t over here, 5 cos 2 pi into 1.5 seconds plus pi by 4. The value comes out to be 5 cos 3 pi plus pi by 4 plus pi by 4. Okay, 3 pi plus pi by 4, that is again minus of 5 cos pi by 4. Okay, as we know 3 pi by cos of 3 pi is equals to minus theta, minus, so minus of 5 cos pi by 4, x is the displacement. So the displacement is given by, we calculate the displacement, we put the value 5 into cos of pi by 4 gives you 0.707, which is the value comes out to be minus of 3.54 meters. Okay, now we find the acceleration, which is equals to omega square x. So we know that acceleration equals to omega square x. Omega is equals to 2 pi square into x is the displacement, which we just found out. It is 3.54. The answer comes out to be 140 meter per second square. Okay, so we have acceleration is 140 meters per second square and the displacement is 3 minus 3.54 meters. Option is C. Okay, which of the following statement is true for the velocity v and acceleration a of a particle executing simple harmonic motion? Options are when v is maximum, a is 0, when v is 0, a is 0, when v is maximum, a is maximum, when the value of a is 0, whatever may be the value of v. So basically we have the equation first for the velocity v, which is equals to omega under root a square minus x square. Okay, so we'll test the values for v. When v is equals to 0, we also have acceleration is equals to minus which is equals to omega square x, which is equals to omega square x. If we put v equals to 0, suppose if we put x equals to 0, so firstly if the displacement x is equals to 0, then we have acceleration is maximum, acceleration is minimum, a becomes equals to 0, velocity becomes equals to maximum. Okay, and suppose if x displacement becomes equals to a, then if x becomes equals to a, then the velocity will be minimum, it will be 0, it will be 0. Okay, and the acceleration will be maximum. So that is when v is maximum, when the v is maximum, okay, v is maximum, acceleration is 0, that is 0. So we have a, and v is maximum, acceleration is 0. Okay, the graph, the xt graph of a particle undergoing simple harmonic motion is as shown in the figure. The acceleration of the particle at t 4/3 seconds is, the options are root 3 by 32 pi square centimeter per second square, minus pi square by 32 centimeter per second square, pi square by 32 centimeter per second square, or root 3 by 2 pi square centimeter per second square. Okay, so here we have given the graph. In this graph, when the time is equals to, the amplitude becomes equals to 1 at the time t, which is equals to 8 seconds after one complete oscillation. Then we use the basic equation, that is equals to x equals to a sine omega t, where we have x equals to 1 sine omega t, which is equals to, we can write it 2 pi by t, small t, into capital T. Omega is equals to 2 pi by t. Okay, so we get x equals to sine 2 pi by 8 t. Okay, next here, after substituting time t, which is equals to 4/3 seconds, we have x equals to sine 2 pi by 3 into 4/3, which gives you the displacement x to be root 3 by 2 centimeters. Okay, now this is the displacement in SHM. We need to find the acceleration. So acceleration is equals to minus omega square x. So where omega is equals to 2 pi square by t square, that is 4 pi square by t square, minus multiplied by x is root 3 by 2. After solving this, it comes to the answer root 3 upon pi square upon 32 centimeter per second square. Okay, so that is the correct option D, root 3 by 32 pi square centimeter per second square. So a block of mass m is attached to a spring of spring constant k. It is free to oscillate with the angular velocity omega in a horizontal plane without a friction or clamping. It is pulled to a distance x0 and pushed towards the center with a velocity v naught at time t equals to t naught. The amplitude of the oscillation in terms of omega x naught and v naught is under root omega v naught square upon omega square minus x naught square, or b under root omega square v naught square plus x naught square, c x naught square under root upon omega square plus v1 square, or d under root omega square upon omega v naught square upon omega square plus x naught square. Okay, so we start with the equations. So when firstly the displacement, the equation for the displacement at time t is a cos omega t plus psi. Okay, where we have got at time t equals to 0, the displacement, the displacement x, which was equals to x naught. So we had x naught is equals to a cos psi. Okay, let this be the equation 1. Next we have again the equation of sine, that is x equals to a sine. Okay, no, we differentiate this equation with respect to, we need to find the velocity. So velocity of is equals to dx by dt. So d by dt of the equation a cos omega t plus psi. Okay, we get the equation to be minus of a omega sine omega t plus psi, that is the velocity. So at time t equals to 0, we have, at time t equals to 0, we have velocity v equals to minus of v naught. So again we have minus v naught is equals to minus of a omega sine psi. Okay, where where the sign, where we have we'll take a ratio of that becomes minus v naught upon minus omega is equals to a sin psi. Okay, so this is your equation number 2. So squaring and adding both the equations, we get a square sin square psi plus cos square psi is equals to v naught square upon omega square plus v naught plus x naught square. Okay, so a becomes equals to under root v naught square upon omega square plus x naught square. Okay, that is your option number D, v naught square upon omega square plus x naught square. The displacement of a particle executing simple harmonic motion is given by x equals to 3 sin 2 pi t plus pi by 4, where x is in meters and t is in seconds. The amplitude and the maximum speed of the particle is A 3 meters 2 pi meter per second square, B 3 meters 4 pi meter per second square, C 3 meters 6 pi meter per second square, or D 3 meters 8 pi meter per second square. So we have, first we'll write the equation x equals to 3 sin 2 pi t plus pi by 4. Okay, we compare it with our general equation x equals to a sin omega t plus psi. Comparing, we get amplitude a equals to 3 and the omega is equals to 2 pi. Now we need to find the maximum speed. So for the maximum speed v max, we have the equation a omega. We have the formula a omega, where a is the amplitude 3 into omega is 2 pi, that becomes 6 pi. So the velocity becomes 6 pi meter per second. Okay, so your acceleration is 3 meters, so your amplitude is 3 meters and your velocity is 6 meter per second. So the correct option is C, 3 meters into 6 meter per second square. A particle executes simple harmonic motion of period 12 seconds. After 2 seconds, it passes through a center of oscillation. The velocity is found to be 3.142 centimeters per second. The amplitude of the oscillation is A 6 centimeters, B 3 centimeters, C 24 centimeters, D 12 centimeters. Okay, so we have a particle which is performing a simple harmonic motion with a time period 2t, which is equals to 12 seconds, and after 2 seconds, so t is equals to 2 seconds, it passes through the center of oscillation with a velocity v, which is equals to 3.142 centimeter per second. This amplitude of the oscillation a we have to find out. Okay, now we have the equation y, which is equals to a sin omega t. We calculate the velocity, which is equals to change in the distance upon time, that gives you a omega cos of omega t. Okay, where omega is given by 2 pi upon capital T. So we calculate the velocity a into 2 pi upon capital T multiplied by cos of 2 pi upon capital T into small t. Okay, your amplitude a we have to find out. We have given the velocity 3.142 into 2 into 3.14 upon time t is 12 seconds into cos of 2 into 3.14, cos of 2 pi upon 12 into 2. Okay, so the entire answer a comes out to be 12 centimeters. So your amplitude is 12 centimeters, option D. Okay, question number 24. The total energy of the simple harmonic motion oscillator is proportional to amplitude, square amplitude, frequency or velocity. So we have the total energy equation, E is equals to half m omega square a square. So E, which has other usual meanings, that is E can be, it is the total energy. So this E is directly proportional to amplitude square. So the option is B, square of the amplitude. A particle, question number 25. A particle executing simple harmonic motion with time period t. The time period with which its kinetic energy oscillates is t, 2t, 4t or t by 2. Basically, a particle which is performing a simple harmonic motion, the kinetic energy of the particle which is executing the same motion, that is a simple harmonic motion, it's periodic with the time period t by 2, half of the total time, so that is t by 2. Okay. A particle executing simple harmonic motion with an amplitude a, the displacement of the particle and its potential energy is half of the total energy is a by root 2, b a by 2, c a by 4 or d a by 3. So we have a particle with an amplitude a. Okay, so the potential energy of the particle is given by potential energy u is equals to half m omega square x square. Okay, and the total energy of the particle E is given by half m omega square and a square. Okay, so that is the total energy and the potential energy. According to the sum, the potential energy U is half of the total energy, half of E. So the equation becomes half m omega square x square, which is equals to half of half m omega square a square. So the total and the displacement of the particle, we need to find the x. So x square comes out to be a square upon 2, or x can be equals to a upon root of 2. So the correct option is a, x is equals to a upon root 2. The frequency of variation of kinetic energy in a simple harmonic motion of frequency n is 2n, n by 2 or 3n. Basically the frequency in the variation of a particle performing simple harmonic motion in the kinetic energy of the particle is given by 2 of n, that is the twice of the n of the frequency n. So the correct option is A, 2n. Which of the following energy time graphs represent the damped harmonic oscillator? Here the energy of the damped harmonic oscillator is given by half a square e raised to minus bt upon n, where here the oscillation decreases exponentially with respect to time. So from all the three, C is the graph in which the oscillations are decreasing exponentially with time. Starting at it was increasing and then it goes on decreasing. So your correct option is graph C. The acceleration, question number 29, the acceleration due to gravity on the surface of the moon is 1.7 meters per second square, and the time period of the simple pendulum on the moon if its time period on the earth is 3.5 seconds, given g is equals to 9.8. The exit options are A is 2.2 seconds, B 4.4 seconds, C 8.4 seconds, D 16.8 seconds. Okay, so here we have for the moon, we have the acceleration due to gravity on the moon is 1.7 meters per second square. Then the acceleration to gravity on the earth is 9.8 meter per second square. Then we have the time total period for the pendulum is 3.5 seconds. We have the find time taken for the period of oscillation on the moon. So that is, we have the formula T, time taken for moon is 2 pi under root L upon G of M. Similarly for the earth, we have T is equals to 2 pi under root L upon GE. Okay, comparing, we have Tm upon T of E is equals to under root GE upon GM. Okay, so Tm is equals to under root GE upon GM into T of E. Calculating, E is 9.8, GM is 1.7 into T of E is 3.5. Calculating the above terms, the answer comes out to be 8.4 seconds. So the correct option is C, 8.4 seconds. Okay, question number 30. The length of a simple pendulum which takes seconds is A 0.5 meter, B 1 meter, C 1.5 meter, D 2 meters. Okay, solution. Here we have the time period for the simple pendulum T is equals to 2 pi under root L upon G. We can write the equation in terms of L, which is equals to GT square upon 4 pi square. Okay, so for the time period for the simple pendulum which takes seconds is 2 seconds. Okay, so substituting all the values, G is 9.8 multiplied by 2 seconds upon 4 into 3.14 square. The length comes out to be 1 meters. Okay, so B is the correct option.